Right, I'm going to show you how to factor by grouping today. And first of all, we're going to list out some steps that we need to follow when factor by grouping. And so the first step is that we need to write our polynomial in standard form. Okay, so make sure the polynomial is in standard form first. And then we're going to group our terms into pairs. Now you do this using parentheses. You'll put parentheses around each pair of terms. Then once you've got your group pairs or terms paired up, you're going to factor your greatest common factor from each pair. So factor the GCF from each pair. And then our last step here is we will factor out the greatest common factor again, one more time. And so I'm going to go through some examples and show you how these steps work so that they will make sense. So let's go ahead and draw a line across here. And let's go into example 1. All right, so we're going to factor 3x to the third minus 2x, and actually that's not a 2x squared, that should just be 2x. So 3x to the third minus 2x, let's see here, plus 6x squared minus 4. So I want you to notice we have 4 terms here. It's not a trinomial. We've got 4 terms, so we're going to need to factor by grouping. So first thing is to write it in standard form. This is not in standard form. The exponents are not going in the correct order. They need to go in descending order. So that if we put it in standard form, 3x to the third will go first, followed by plus 6x squared, and then minus 2x, which was 2x to the first, and then minus 4. Okay, now we have it in standard form. Second step says to group them into pairs. So I'm going to put parentheses around the first pair and then parentheses around the second pair. Notice where I put this parenthesis. I put it in front of the minus sign. So whatever sign is with that third term, put the parenthesis in front of that sign, whether it's a plus or a minus. And now I look for the greatest common factor for each pair. So for this first pair right here, that greatest common factor, let's see, the largest number I can divide both of these by is 3. Both terms contain x, so I go with the smaller exponent, which is x squared. So for the first pair, our greatest common factor is 3x squared. And then for the last pair, let's look for the greatest common factor for that pair. Well, let's see, I can divide both of these by 2. And since this starts off negative, if this starts off negative, the greatest common factor must be negative. So it's going to be negative 2. They don't share a variable, so it's just negative 2 there. And if you recall, when we factor out the greatest common factor, we are actually dividing each term by that factor. So I'm going to be dividing each term in the first pair by 3x squared, and I'm going to be dividing each term in the last pair by negative 2. All right, so when I factor out that greatest common factor, let's write it in front. So I've got 3x squared, and then if I divide each of these by 3x squared, what will I have here? Well, let's see, 3's cancel. X to the third divided by x squared. Subtract those exponents, and you have x to the first power plus 6 divided by 3 is 2. X squared over x squared cancels out. So it's just 3x squared in front of x plus 2. All right, for the second pair, the greatest common factor was -2. And then when I divide each of these by -2, let's see, the signs change. Negative divided by negative, this is going to be positive. 2 divided by 2 is 1, and then x. I don't have to write the 1 in front of the x. I can just bring it down as x. And then here, -4 divided by -2 is going to be a positive. 4 divided by 2 is 2. All right, so I've got 3x squared times x plus 2 minus 2 times x plus 2. So I'm thinking of these as this term and this term. So all of this together, all of this together. So now I'm looking at the greatest common factor for each of these. So the greatest common factor of these two, well, what do these two have in common? They both have x plus 2. So when you are factoring by grouping, you should end up with the same factor inside parentheses. Like we have x plus 2 for both of these, that is what's supposed to happen. So if I factor out that greatest common factor there, so I want to point out, mark here. So it is important to note that these are the same. That is what is supposed to happen. You should have the same thing in parentheses like that. So when I factor that out, that greatest common factor from each of those, I have x plus 2. And then when you factor that out, if I take it out from each of those terms, you will be left with 3x squared minus 2. 3x squared minus 2. So the result of factoring by grouping here is going to be x plus 2 times 3x squared minus 2. And notice that we end up with 2 binomials. So when you do factor by grouping, you should end up with 2 binomials like this. All right, we're going to do one more to practice this. So draw a line across, and this is going to be example 2. Okay, example 2. So let's say we have, we're going to factor y to the third plus 7y squared plus 14 minus 2y. First thing, this is not in standard form. Look at your exponents. 3, 2, there is no variable here. That's an exponent of 1. So we need to switch these last two terms, and we will have y to the third plus 7y squared minus 2y plus 14. Good. Get it into standard form first. Put parentheses around the first two, parentheses around the last two, and then factor out the greatest common factor. So in the first pair, let's see. Numerically, it would just be 1, but they do have the same variable. They both have y, and the smaller exponent in this case is 2, so we can actually divide both of these by the greatest common factor, which was y squared. Okay, so here our greatest common factor was y squared, and when I factor that out, let's see, subtract your exponents here. That's going to be y to the first power plus 7. The y squareds cancel out there. So it's just y squared times y plus 7.
Teachers, at this time, please release students who have third period A lunch.
All right, so now in the second pair, notice you can divide both of these by 2, but since this starts off negative, it's going to have to be a -2. So divide each of these by -2. So that -2 right there, that is that greatest common factor that we are taking out. -2 divided by -2, well, that cancels, just leaving y. 14 divided by -2 is -7. And notice we have the same thing in parentheses. I say that, but the signs have changed. Hold on. Let me check something real quickly. Oh, because this is supposed to be plus 2y at the end. So that's actually a positive. So the greatest common factor is positive. I apologize for that. I wrote the problem down wrong. That is a plus 2y. So our greatest common factor is actually positive 2. 14 divided by positive 2 is positive 7. That makes so much more sense. So now, looking at these two, they have the same thing in parentheses, y plus 7. All right, so we factor out what they have in common, which is y plus 7, and then we put the remaining terms in parentheses here. So if I take out the y plus 7, I am left with y squared plus 2. And that is the result of factoring the original polynomial. Y plus 7 times y squared plus 2.